This video is on solving exponential equations where the base works nicely. We're going to use a different tool set than if the base was more challenging. This method only works for nicer numbers. So if you want to skip this video and just move on to the more complicated problems where the bases are different, you absolutely can do that. This is almost like a shortcut method for easier problems. For this method, we're going to use something called the principle of exponential equality, which is a wonderful name for saying something that I think we can look at and probably agree that it's obvious. If we have some numbers with the same bases and they're both raised to some powers, this means that those powers are equal. So if I have 2 to the 7th power equals 2 to the x power, and these are equal, I can conclude that 7 equals x. Our strategy for these problems is to write them so the base is the same. Looking at the number 4 and 64, there's something to do with 4 about the number 64. And if you draw a factor tree or just think it through, you'll soon realize that 64 is 4 to the 3rd power. We could also break both of these down into a base of 2 and deal with the exponents from there, but 4 is going to be a little bit easier. So I can rewrite this problem as 4 to the 2x minus 3 equals 4 to the 3rd power. Since the base is the same, the principle of exponential equality says that 2x minus 3 equals 3. Now we have a linear equation. We know how to solve these. Add 3 on both sides. 2x equals 6. Divide both sides by 2. X equals 3 is our answer. We can check this by taking the 3 and plugging it back in wherever we see x. I'll leave that to you. This next problem, we have a base of 9 and a base of 3. I know that 9 can be rewritten as a base of 3 because 9 is just 3 times 3. What we have is 3 squared to the 4x power equals 3 to the 5x minus 6 power. In parentheses, when we have a power raised to a power, we multiply those exponents. This becomes 3 to the 8x power, because 2 times 4x equals 8x, equals 3 to the 5x minus 6. Now that our base is the same, we can just equate those exponents, and we have 8x equals 5x minus 6. Subtract 5x both sides, 3x equals negative 6. Divide both sides by 3, x equals negative 2. There's our final answer. Let's go ahead and do the check. It'll be the last thing on this video. 9 to the 4 times negative 2 power equals 3 to the 5 times negative 2 minus 6 power. This turns into 9 to the negative 8 power equals 3 to the negative 10 minus 6. Negative 10 minus 6 is negative 16. Plugging this into the calculator, I've got 2.323 times 10 to the negative 8. My calculator actually displays that as e negative 8 instead of times 10 to the negative 8, but it means the same thing. And on the other side of this equal sign, we get the same exact thing. 2.323 e, or times 10 to the negative 8 power. The problem checks out. Thank you.